Good evening. So tonight I wanted to create a video for you to show you how to balance a combustion type of chemical reaction. And we know it's a combustion reaction because we see a hydrocarbon, as we can see right here, which is reacting with oxygen to form CO2 and H2O. So we're going to go ahead and take some time here to balance these reactions so we can see the process and how to go. And so the easiest way to balance these is to create our inventory and to understand that we're going to balance them in the order of carbon, hydrogen, and oxygen. If we can balance it carbon, hydrogen, oxygen in that order, it's going to help us to keep things in order and keep things organized as we work our way through. So we first set up our inventory and we can count that there are 7 carbons on the reactant side. We see the 7 right there. For the hydrogen, we can see that there are 6 there. And for the oxygen, we can see there are 3 there, and then 2 more here for a total of 5. On the product side, for our carbon, we can see the 1 there in the carbon dioxide. We can see 2 hydrogens in the water, H2O, and we can see 3 oxygens right there. And this is question letter U on the handout that I gave you previously. So to balance the carbon, the first thing we're going to recognize is that we have 7 on the reactant side, 1 on the product side. So we'll take and put a coefficient of 7 in front of the CO2. That's going to change our carbon inventory to 7 now. And the oxygen is going to be 7 of the O2s in CO2. So there's 14 plus 1 more is a total of 15. So now we're going to balance our hydrogen. We can see that we have 6 here. We use a coefficient of 3 in front of the water right there. That's going to change our hydrogens to 6. 3 H2Os, that includes 6 hydrogens. And then we want to count our total oxygens. We've got 7 times 2 is 14, plus 3 more is 15, 16, 17 oxygens. So now what we want to do is we want to try to come up with the appropriate number of oxygen atoms here. So to do that, we're going to recognize that we have 3 here, which means we need to have 14 total oxygens more in addition to those 3. If we change a coefficient in front of this, it's going to change those 3. So what's convenient about that is if we take and put a coefficient of 7 in front of our O2, that's going to give us 14 oxygens right here. 7 O2s is 14 oxygens, plus 3 more here gives us a total of 17. So then we're balanced in this reaction, and we can see that the balanced chemical equation would be C7H6O3 plus 7O2 yields 7CO2 plus 3H2O. Okay, sorry for the mixed up scribbled C right there. This is a different program I'm using for the notebook this year, so it looks a little different. Let's take a look at another example. This example is example X from the same handout. You can see it's also a combustion type of reaction. So let's go ahead and set this up first by looking at our inventory. So we've got carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. We can see with the carbons, there are going to be 15 of them in the C15H30. We can see the hydrogens, there are 30 of them. And we can see with the oxygens, there are 2. On the product side, we can see in the carbons, there are 1 there. In the hydrogens, there are 2 in the H2O. And in the oxygens, there are a total of 3, 2 here and 1 more here. So to balance the carbon and carbon dioxide, first we're going to put a 15 as our coefficient in front of CO2. That changes this to 15. Now we want to count the number of oxygens we have left. We have 15 times 2, which is 30. Plus don't forget about that 1 there, which will make it 31. Now we're going to look at the hydrogens. We can see 30 hydrogens here. We know that we have 2 here, so we can put a coefficient of 15 in front of this. This is going to give us our 30 here as well. And now we count our oxygens. 15 times 2 is 30, plus another 15 is a total of 45. Now the problem we see here is that there's no number of there's no coefficient number we can put in front of our O2, which will give us 45, unless we want to call this 45 over 2, which is acceptable. So what I suggest everybody do is, rather than doing that, we go ahead and we say, all right, well, if we double all of our coefficients, put a 2 in front of this, change this 15 to 30, and change this 15 to 30. I'm not sure why I just did that. It should be 15 going to 30. We can see that this inventory is going to double to 30 carbons, 60 hydrogens, and 90 oxygens. And on this side, it's going to give us 30 carbons, and it's going to give us 60 hydrogens. We still have the 2 oxygens. So now how can we go to 90 oxygens in O2? Coefficient of 45. So that changes that to 90, and then we're balanced. We can go ahead and rewrite that chemical equation. 2C15 H30 plus 45 O2 yields 30 CO2 plus 30 H2O. Okay, we can take a look at one last example, and this is example letter Z from the same handout. So again, we'll set our inventory up. First thing is carbon, hydrogen, and oxygen, as we've done before. Carbon, hydrogen, and oxygen. We can see when we look at this that we've got 12 carbon, we've got 26 hydrogen, and we have 2 oxygen. On the reactant side, 1 carbon, 2 hydrogen, and 3 oxygen. So to balance the 12 carbons, we'll use a coefficient of 12 in front here. Changes our carbon to 12. The oxygens become 12 times 2, 24, plus 1 more is 25. Now for the hydrogens, we can see there are 26 hydrogens here, so we can put a coefficient of 13 in front of our H2O. That's going to change our hydrogen to 26. That's going to change our oxygen to, don't forget the 12 times 2 is 24, plus another 13 is 37. Okay, so now again we run into the same problem we had before, which is there's no number we can put in front of O2 to get 37. So we go ahead over here, and I'll try to use the darker blue this time. Let's go with orange actually. Yeah, green. Green feels good. Okay, and we're going to take and double all of our coefficients. 2 of those, instead of 12 CO2, we'll go to 24 CO2. Instead of 13 H2O, we go to 26 H2O. And so now what that's going to do is going to change our inventory here from 12 to 24 carbons, from 26 to 52 hydrogens, and from 37 to 74 oxygens. On this side, it changes your carbon to 24, and it changes your hydrogen to 52. So now what are we going to put in front of the O2 in order to get 74 oxygens? Coefficient 37. Okay, and then when we go ahead and write our final balanced equation, we can see that it's going to be 2C12 H26. Try that again. 26 plus 37 O2 yields 24 CO2 plus 26 H2O. And that's pretty much it. The key with balancing a combustion reaction is to make sure that you first balance your carbon, then you balance your hydrogen, and you balance your oxygen last. Because if you can just add oxygen, you can figure out how to manipulate your coefficients in order to get exactly what you need. I hope this was helpful, and I wish you well.